Our next discussion is about voltaic cells. That is after looking at the electrochemical cells. So now, voltaic cells are electrochemical cells where chemical reactions generate electrical energy. There are two types of voltaic cells. Primary cells and secondary cells. Let us first talk about primary cells. These are cells that once the reactants are used up, they can't be stored and therefore do not provide continuous supply of energy. Examples of such cells are dry cells, which are used in a wide range of electrical applications. An example of a dry cell is a lectern cell, which consists of the following. It has a cell has zinc cap, which forms negative terminal. It has graphite rod, which forms positive terminal. The graphite rod is surrounded with ammonium chloride paste, zinc chloride, and manganese 4 oxide mixed with carbon. The ammonium chloride must be in paste form, since dry ammonium chloride does not conduct electricity. Dry does not conduct electricity. The powdered it is powdered to increase the surface area of the positive terminal. Let's have a diagram showing the primary cell. Like we have said, in the primary cell there is zinc cap, which forms the negative terminal, graphite rod that forms positive terminal, and this graphite rod has the zinc chloride and ammonium chloride, and this ammonium chloride, we have said, has to be in paste form. Again, the graphite rod is surrounded with as well manganese 4 chloride. Manganese 4 oxide, sorry, mixed with carbon. So this is the dry cell. This is the diagram of the dry cell, and we want to look at now the equations taking place at the terminals. Let's look at equation that takes place at the negative terminal. Remember, the negative terminal is where we have the zinc cap. Equations negative terminal. Always there is oxidation, so that is zinc solid oxidized to give zinc ions. Then at the positive terminal we have ammonium ion gaining the 2 electrons to form ammonia gas and hydrogen gas. This one has energy as E value of negative 0.76 volts. This one has positive 0.74 volts. Let's calculate the E of the cell. EMF is not cell will be E reduced minus E oxidized. So that is 0.74 minus 0.76. That gives plus 1.5 volts. So the cell representation will be as follows. Cell representation will have zinc solid, oxidation to that, then ammonium ion being reduced to form a mixture of ammonia gas and hydrogen gas. Then E is equals to 1.5 volts. So this is carbon stroke graphite. Both ammonia and hydrogen gases produced when left and reacted will coat the carbon terminal, and this reduces the conduction efficiency of the positive terminal. Hydrogen gas is therefore eliminated by being oxidized by manganese 4 oxide. Ammonia gas dissolves in water, or it forms a complex with zinc chloride, and that is how the ammonia will be removed. So this is zinc chloride forms a complex with ammonia, the tetraamine complex. That is zinc chloride tetraamine. That is all about the primary cell. Let's discuss secondary cell, the second type of voltaic cell, that is secondary cell. These are cells that can be reused after recharge. So these ones can be recharged. Remember, primary cells cannot be recharged. For example, when they are in use, reactants get used up. However, they can be restored by reversing the reaction. This is by reversing the reaction. An example of such cell is lead acid accumulators, which consist of the following. An example is lead acid accumulators having lead plate which makes negative terminal lead 4 oxide, lead 4 oxide plate which makes the positive terminal. Both the terminals are dipped into sulfuric 6 acid. When the cell is in use, the following reactions take place. Reactions. We have at the negative terminal lead solid will be oxidized to lead ion and 2 electrons are lost. At the positive terminal we'll have the lead 4 oxide reacts with the hydrogen ions from the acid, and that gives lead 2 ion plus 2 moles of water. The lead ions get into the acid and react with sulfate ions from the acid, leading to formation of insoluble lead 2 sulfate. Lead ion reacting with sulfate ion to form lead 2 sulfate that is insoluble. Hence, the overall reaction will be will have lead plus lead 4 oxide plus the sulfuric 6 acid, leading to formation of lead 2 sulfate plus water, because the lead formed react with sulfate to form the lead 2 sulfate. So this is the overall reaction when it is discharged, when in use. So that is a combination of the reaction at the cathode and anode. In our last lesson, we were talking about the secondary cell, of which we were to move on to the secondary cell diagram and then see the overall reaction for the cell. So the overall reaction that we were just in a process to finish in our last lesson was lead solid